I'm going to begin this session by acknowledging I made a mistake, and when I was talking about removing the bearing from the differential drive shaft, I pointed to the small bearing splitter, and in fact I used a large one for the size of the bearing behind the pinion. I'm now moving on to the reassembly and beginning first with the differential drive shaft bearings, which, as I said, came off with difficulty, and the puller tore chunks out of the shims because I was not getting it to grip until I used the vice grip. But I don't think this is too serious. I'm putting that torn spot at the recess in the housing, so I'll still have the effective thickness of the shim at that location. And I'm going to try and remember to give the nominal sizes that I found taking this apart. On the back side of the ring gear, it had a 30 and a 5, and now it's got a 30 and a 5 and a 10 on top of the 5, as I've moved the 10 from the other side to reduce the backlash from what it was. And there's another tool on the bench. I've scrounged the wife's toaster oven. Instead of beating on bearings or cups, I like to heat the cones if they're going on the shaft, and chill the cup in the freezer for whatever good the chilling might do. I'm setting the oven at around 300 degrees and aiming for a temperature around 280 to 300. I'm using this inexpensive modern device and checking the temperature at the cone from time to time, and shooting that inner cone. And in this case, 219. I had it previously at 280, so I think it's varying back and forth. I'm going to go ahead and move that one, or move the other one, well, I'll move that one on to the differential and hope that it slides on. I've put the puller disc that was from the differential puller kit on here as a pilot, so I can go down with some guide for alignment. I've got the old bearing sitting here in case it doesn't go all the way and it needs some help, and I've got a driver disc and a hammer ready. If it does go all the way, I'm just going to hold it down for a bit with the cup here, just so it takes a seat on the shims. So I'll try this first one here. So if my temperature indication was correct at 220, that one took some driving. It went on without much difficulty, using the old bearing as a driver because it does sit below the tower height on the differential, so I couldn't just do a disc. It would bottom out before the bearing was down. That backside bearing is against the shims now, and I've turned the temperature up. I'd rather get it between 280 and 300 if I could, from what I've seen in the past for being safe to the bearing and better for driving. And now we're at 320 on this one. We'll see how this one compares for going on. And I've got the 10,000 shim. There were two 10s there. Now there's only one on the gear side. I'd seen them slip on in that 280 to 300 degree temperature, but that they both went on far easier than they were to break loose and come off, but that gives you an idea why they're difficult to take off probably. So those two are on, and we'll move on to the differential drive shaft cup. Again, if anyone is starting with completely separate parts and doesn't know where to begin, I'm trying to give the dimensions of shims that I've found in here. There were 6 10,000 shims in the differential drive shaft. I don't know if that's nominal or normal or not. And I'm hoping I'm aligned in there. And I've got the press ready. Not to say that the chilling makes that much difference, but that gives an idea of what I'm doing for the heating the cones and chilling the cups, and similar procedure for the other bearings and cups in this transmission. At this point I have the four bearing cups installed after chilling them. The driving went fine. Alignment of course is the biggest issue to get it started. If this bearing, which is shorter than the end of the stub shaft on the transmission drive shaft, doesn't slip on, I have this socket ready in my press for that trick to push it on home. Let's see, the temperature of the inner race of that rear bearing is at 306. So let's see if it'll slide on, and if not I'll take a pause and use the press to finish it. I've been putting a little bit of grease for whatever good it might do with a hot bearing. Nope, that's going to need a push. The way things are going here, the temperatures aren't maybe high enough for bearings to slip on, and I don't like taking them too much over 300. So for the front bearing on the transmission drive shaft, which sits on these splines on the raised section there, I have the press ready at the right height in case I need to use the old bearing to get the bearing to seat. And presently this one is at 140 Celsius or 283, so at the rate we've been going it probably will not slide on. If it doesn't, we'll take another pause and I'll go to the press and do what's needed over there. Finally, this bearing was the one that's the easiest to remove since it's on that raised spline section in there, but that's the slip fit that I've been looking for in that 280 to 300 degree temperature range for the others, but not holding the high temperature. I have turned the oven up a bit, and now I'm ready to do the differential drive shaft bearing. For the differential drive shaft, in case the bearing doesn't slip on at the temperature of over 300 when I checked, I have the original bearing, but I don't want it to stick on the surface there, so I have a washer which ideally would be just the size of the race. In fact, it's a larger OD than what I'd prefer, but I think it is safe. I don't want to get in there and have to be using a splitter or something to get it back off. The temperature on the oven, I've turned it up a bit, and this bearing now 160 Celsius or 319 Fahrenheit, and we'll see how this goes. That again is what is good to hear. And at this, I think if you compare notes elsewhere, I think this 320, 300 range is safe for the bearing, no discoloration or anything. And that I think is a safe practice to avoid beating on things with hammers and punches and distorting cages and so on. That's a good time to show, assuming I don't shake the bearing loose, the minus 24 on the end of the shaft. That was the cone point setting dimension. Again, it's not going to show up very well, but There's a minus 24 there with some other dimension, or with some other letters and numbers. So with all the bearings loaded, now we're ready, assuming my cone point setting is correct, which we can validate later, and I'll try to give better light to check it. The next step, or the first step in checking that, will be to set the preload on the differential drive shaft bearings, and to do that, of course, we have to start with end play. So next shot will be checking the end play and a discussion on the preload and the rolling drag torque on the differential drive shaft.